question number 13 here. We've got midpoint of 2 points. And we've got a line with the equation y equals negative half x at 4. We want a line that goes through the midpoint and is perpendicular. So if we think about this line, looks something negative half, so it's something like that. I've got 6, 1, and I've got negative 2, that'll be the other way around. I've got negative 2, 5, and I've got 6, 1. I'm looking for something that goes through here, and it's perpendicular. So I know when it's perpendicular, it cuts through at 90 degrees. First thing I need to do is work out my midpoint. So my midpoint of this one, I'll look at the x values. Well, the x value are 6 and negative 2, so I add them together. 6 times negative 2 divided by 2, and then I look at my y values, and I've got 1 and 5 divided by 2. So the midpoint of m is 6 over 2 is negative 2 is 4, 4 over 2 is 2, and 1 and 6 is 1 and 5 divided by 6 divided by 2 is 3. So it's the midpoint of 3. It's perpendicular, so it's got a gradient that is the negative reciprocal of negative a half. So the gradient is positive 2. So I know my graph is going to be something like this, y equals 2x at something. And I also know it goes through the point 2, 3, because that's the midpoint. So my graph, just substitute in those values because I know it goes through there. So y is 3, 3 equals 2 lots of 2, that's whatever c is. And 3 equals 4, that's c, c equals negative 1. So ultimately, the name of my graph is y equals 2x negative 1. There you go. Question number 14 on the next page. In the winter, the farmer feeds his cow with hay each day. The number of days the hay will last is inversely proportional to the number of cows that the farmer has. So, I need to set myself up a little equation. Well, I know the number of days is inversely proportional to the number of cows with a constant there. And I can just substitute in the values that I've got. Because the farmer has enough hay to feed 280 cows for 25 days. So K gives me 25 times by 280, K is 7,000. So my constant value is 7,000. Okay, so I know that I've got 7,000. I go back to my equation now. So I've got days is 7,000 divided by the number of cows. That's it. 7,000 divided by the number of cows. That's those. For the second part, the farmer has, I'm not copying it over, but I'll just tell you now, for part B, farmer has 350 cows. How many days can he feed them all these cows with hay? Well, I start with my formula, 7,000 over C, and over C is 350. So just do D is 7,000 divided by 350. So D, 700 divided by 35. That gives me 20 days. So with 350 cows, you can feed them with his hay for 20 days. That's that one. And come finally to this one. I'm going to just make that a little bit on the bigger side. It's a bit small there. Right, hot drinks served at a temperature of 70 degrees. Graph shows the temperature of a hot drink as it cools in a china mug. Now, on your version, you've not got a tangent drawer. I've snipped this from a work solution booklet, so I do have a tangent drawer. It's asked for my rate of cooling. So I know that the rate of cooling is the gradient. The gradient gives me the rate. So it's the rate that the temperature is dropping as the minute passes. Well, if you think about what gradient means, gradient is rise over run. Well, the temperature is rise, the change in y, divided by the change in x, which is time. So the rate of cooling, if I look at 25 minutes, if I go up here, you can see at 20 minutes, I've drawn myself a tangent. So now, with that tangent, I'm looking for a couple of points. I'm looking for there. There is 39 and 15. Yeah, that's a nice easy number to be able to read. And if I go up here, I go along, I've got 20 and I've got 40. So my gradient is the change in y over the change in x. So if I look, I've got a drop of 19, just about where it meets. So it's negative 19 because I've gone from 39 to 20. And then my change is positive 25 because I've gone from 15 to 40. So I look at my gradient there, I can just put that into a calculator. Negative 19 over 20 or negative 0.76 degrees per. Right? You get a little bit of leeway with that. You could have it's cooling, so we can either say it's cooling at 0.76 degrees per minute, or we're looking at the gradient, it's negative because I'm losing 0.76 degrees per minute. Either one. And that's